All right, so this problem is called Eating Breakfast. And it says a researcher claims that no more than 55% of U.S. adults eat breakfast every day. All right, so in a random sample of 250 adults, if you find that 56.4% say that they do, is there enough evidence at the 1% level of significance to reject the researcher's claim? All right, so let's get some space to work on. All right, so if this is a problem about some kind of a claim, and we're looking to establish the researcher's claim or not, what kind of problem is this?
Hypothesis testing?
Yeah, it's a hypothesis test, right? Because a hypothesis test is always one where you want to establish whether a claim, and the claim's about a population proportion, right? Another dead giveaway is this thing called a level of significance. If they're talking about significance, they're talking about a hypothesis test. So we know for sure this has got to be a hypothesis test. Now let's see, the hypothesis test, for a hypothesis test, you have to look at a couple things. You have to establish what the null hypothesis is that you want to test, and then also what the alternative hypothesis is. That's the other thing you might establish. Now, for the null hypothesis, you're looking to see a claim about the population proportion. The null hypothesis is always in the form where the population proportion has got a certain size. So here, what is the claim that's being made, and what's the proportion that we're after here? So it's either, it looks like there's a 55% up here, but there's also this 56.4% over here. The 56.4% says that it comes from our sample. So that's not going to be the population proportion, right?
Right.
So it's got to be, it's the 55%. So how do we write that over here? It's the population proportion. What's our symbol for population proportion?
It's the...
It's a theta, right?
Yes.
Okay, so theta is equal to 0.55.
Okay.
All right, so that's the null hypothesis.
Okay.
Now, if we want to see, so the null hypothesis, the null hypothesis here should be about the researcher. Researcher claims that no more than 55% of U.S. adults eat breakfast every day. Now, if we're going to think about the alternative to that, if the null is at no more than 55%,
then you have to deal with the 56.4.
That's right, and the 56.4 is going to be the sample proportion, but I'm trying to think about what form the alternative hypothesis is going to have. So it's either that we're trying to show that the population proportion is not equal to this 0.55, or it's bigger than this 0.55, or it's less than this 0.55. Can you tell which it is for this one? So up here, if it says that the claim is that it's no more than 55%, then the opposite of that would be that it's actually what?
More than 55%.
Yeah, more than. So let's write the alternative like this. Bigger than 0.55.
Right.
All right, so that's the two things we're trying to think about. Either the population proportion is 0.55, or in fact it's bigger than 0.55. Now we already said that this over here, the 56.4 is our p hat, so let's write that. That's 0.564, right?
Right.
And let's see if we can draw a picture of things now. All right, so here's the p hat, and we're going to take p hat values and change them into z values, right? Okay. And over here in the center, yeah, what's the question?
Okay. How come you changed it to 0.564 if it's 56.4?
Because we're whenever you look at percents in terms of p hats, you always write them as decimals.
Okay.
So like the 55% up here, we're going to deal with it as 0.55, and that means we got to deal with this 56.4% as 0.564.
Okay.
All right. So what goes in the middle here for the p hat distribution?
The theta.
Yeah, and the theta this time that we're trying to test is 0.55, right? So let's put that there.
Okay.
All right, now in relation to that, where is this sample proportion, the 0.564?
That's to the left of it? Nope.
Smaller?
It's to the right of it,
to the right.
It's larger.
Bigger, yeah, 0.564 over here. Okay, good, that's our p hat.
Okay.
And now, if we're doing this kind of test where we're looking at the population proportion bigger than 0.55, that's called a right-tailed test. And you can tell that because you're testing to see whether or not theta is actually bigger than 0.55. So the area that we're interested in over here, once we change things into z-values, is this area that's to the right of our sample proportions. We're looking for this tail up here. So when we change things over here into z-values, what winds up in the middle here? To this.
The z.
Yeah, for the
Z4?
z. Yeah.
The theta.
It's this 0.55 right here. Yeah, that's right. And it winds up being the 0 here. So that means this 0.564 has got to wind up to the right of 0 or to the left of 0.
To the right?
Yeah, to the right. Okay. And we'll see. We'll get the same sort of area over here as well, too. And that's the area we'll wind up looking up when we actually use the table after we figure out what the z value is here.
Okay.
All right. So that's what we got to do is put a question mark for the thing we want to compute. That's the z value that goes right there.
Right.
All right. Now, there's something else involved here that we need before we get started here. That's what's this 250 up here for the sample, the random sample of 250 adults. And that's what's called a sample size. And that's going to go in here as well too. We'll need that when we compute our z value. So that's 250. So let's label that with an n.
Okay.
All right, now, so we're going to change things into z values now. Give me the formula for z-score.
Okay, it's the data
Minus mean.
minus the mean over
That's
standard deviation.
Perfect. Okay. Now, what do we got? The data this time is what?
250?
No, that's the, what is that? That's the sample size, right?
Right.
So the data we're looking for values down here, these values on the p-hat axis right here.
Right.
Let's start with the mean. What's the one?
Okay.
What's the mean? The mean is what?
0.55.
Yeah, it's the thing in the middle.
Right.
That's right.
Okay.
And so the data's got to be what?
The 0.564.
That's it.
Okay.
Good. All right, now, what about the standard deviation? How do we get the standard deviation?
You use the formula for standard deviation.
All right, wait a minute. Let me get it down here. Tell me what it is.
It is, underneath that.
Square root.
Theta, and then in parentheses, 1 minus theta over n.
That's right. Okay, so I'm going to use theta 0, where theta 0 stands for this value right here that's 0.55, right?
Okay.
Okay, so that's going to be 0.55 there, and then it's 1 minus 0.55, right? And then on the bottom, our sample size we said was what, 250?
Yes.
Okay, so I'm going to need to compute 0.55 times 0.45 divided by 250.
5 times 0.45 divided by 250.
And then when we finally get that, take the square root of it. Yeah. Tell me what you get.
I got 0.031.
0.03146. 4. Let's carry on 4. Okay, so we have 4 places here. That should be good enough. So 0.0314 goes up here. Okay, so the next thing I need you to compute is 0.564 minus this 0.55.
Okay, that equals 0.014.
Okay.
And then divided by
0.0314.
0.0314 equals 0.4458.
Okay, that's good. So 0.445 is good. That's our z value.
Okay.
That's this value up here that we computed. 445 right there.
Okay.
All right, now in order to get the rest of this, I need the area of this tail to the right there, and that's called a p-value. All right, so our p-value is that area. So I just need to look up the area to the right of this 0.445 as a z-score. How do I find that area? Do you know?
That's a good question.
What does the table look up?
Yes,
the table looks up areas from the left-hand side up to the z-value, right?
Right.
So if we're looking for the area to the right of a z-value, I need to do what to it?
Subtract something from it.
Yeah. Subtract it from 1. I need to subtract the what I look up in the table from 1, right?
Yeah.
Because I want to get this area over here. I look up the area in the table. That's this area from the left-hand side all the way up to this value. If I want what's left over from 1, I need to subtract it from 1, right?
Okay.
So we're going to do this. 1 minus table lookup. And our z-value we said was what, 0.44? 445. Okay, so go to the table and find 0.4, let's round off, 0.45. So find the z-value, or find the z-score 0.45, and tell me what the size is.
It's 0.6700.
And let's do this one, 0.45, because this would round off to 0.45.
Oh, okay,
So let's do the next one.
0.67 0.6736.
36. Okay, now take that guy and subtract that from 1.
Okay. Should I do it right now?
Yeah.
Point 3264.
Good. So oops, wait a minute. 0.3264. Okay, good. So that's our p-value, actually. This is the area that I'm after. That's our p-value. So let's write it up here. So p is equal to 0.3264. And that's the thing I can make my conclusion from, right?
Yeah.
Once you have the p-value, then what you do is you take the p-value and you compare it to the level of significance if you're given one. If you're not given one, you look it up in a table that tells you what kind of evidence you have about the null hypothesis based on the size of this p. And generally, the smaller the p-value, the worse the evidence is against H0, or the more evidence you have against H0, depending on how small the p-value is. In this case, the p-value is 0.32, and I'm going to go compare it to my alpha of 0.01. Now, is this p-value smaller than that alpha?
Yeah.
0.32 smaller than 0.01?
No.
It's not, right?
No.
Okay, so if the p-value is smaller than this alpha, then that leads you to reject this H0 up here. But if the p-value is bigger than this, then the way people say that is that they failed to reject H0. Okay, now let's see if we can figure out what that means.
But
We
it's
failed.
not significant.
That's right. It's not significant. The other word that people say about it is they say it's not significant. That result is not significant. Okay. And let's see if we can make sense of what we're trying to do. Our researcher claimed that no more than 55% of U.S. adults eat breakfast every day. And according to our test here, we kind of tend to believe that, right? Because we failed to reject that claim. And we found that our p-value actually was pretty big, 0.32 compared to the 0.01. So really, we kind of tend to believe this H0 in this case. We kind of believe that the researcher was telling the truth. Okay.